since these are on the board, can y'all work in your group to try to figure it out? You'll need your calculators and pencils and paper.
I do. Your teaching is cool. Yes, just seniors.
Pretty much.
Awesome.
I'll give y'all a hint. Y'all need to consider the if not part of this equation or problem. So if James does not call the right heads or tails on the coin.
It's like a 50-50 chance.
Yes. So if not, Mike gets to pick between one of the numbers and roll the die.
So would it be James because there's like a 25% chance? Or like it would be Mike because there's a 25% chance that James would have to get both correct on the coin flipping to even go further?
Are you saying James would be the winner?
No, I'm saying like James would have less of a chance.
Did you consider the spinner? Talk in the groups.
Right, because if they look at the
Morgan.
So the chance between if you roll the die and get
Yeah.
So let me give me one of their answers on who they think is more likely to win.
That's James, right?
Mike.
The spinner.
Yeah.
Like the bottom number, like it does 1/5 the first time, is it 1/4 the second time? What is those?
No, it should be 1/5. Okay,
wait.
so. Okay, so does anybody have an idea on who they think won? Mike. Mike, why?
James has to do a lot more stuff to get it, just in general.
Okay, but like James would have a better chance because he gets the first thing, and like if he doesn't do both of them right, then Mike might get a chance.
Okay, so let's just calculate the probability James has at winning the last bit.
I'm sorry about my pens. I need to get new pens. I meant to do that this weekend. They're just all running out.
Okay.
Yeah, that's good.
Okay, so it says first, Mike flips a coin twice, and each time James calls heads or tails in the air. If James gets both calls right, he gets the last cookie. So what's James' probability? 1/4. Okay, and so you get that from the half and the half. So then, if not, Mike gets to pick a number between 1 and 6 and then roll the die. So let's go on and write that down. Okay, so for this problem, and I think most of you are probably missing this, you have to, for Mike to get to pick the number on the die, James has to get both of them wrong. So you have to account for that part. So you have to write the 3/4 times the 1/6, which is the probability that he chooses that number on the die, and that's 3/24, which is 1/8. Does that make sense? Okay. So then if he does not get the number on the die correctly, then James picks two numbers between 1 and 5 and then spins the spinner with the numbers 1 through 5 on it. So then it comes back to James, and for it to come back to James the second time, he has to get the coin toss wrong. Mike has to call the number wrong on the die, so that's 5, 6. And then for him to get the spinner correctly, it has to be 2/5. Does that make sense?
Yeah.
And so then you multiply that and it becomes 30 over 120 which is 1/4, and you add 1/4 plus 1/4 is 1/2. Does that make sense? Okay, and so then if it says if the spinner lands on one of James' two numbers, he gets the last cookie. If not, Mike does. So then we come back to Mike, and for it to come all the way back to Mike to get the last cookie, we have to like include all of this probability, and it'll be the same exact thing as this, except it will not be 2/5 because he will have a 3/5 chance of not landing on James' number. And so then that probability is 45 over 120, I think. And then that's 3/8. And then 3/8 plus 1/8 is 1/2. Does that make sense? So they both have an equal probability of winning. Okay, so today our objectives, so by the end of this class, you should be able to design and conduct a simulation to model a given situation successfully. Distinguish the difference between subjective probability and empirical probability without error, and discuss the difficulty in calculating theoretical probability accurately. So we're going to do an activity today, and by the end of this class, you'll be able to talk about these and discuss the differences. And our essential question is, how do you model real-life situations using probability simulations? And now we're going to play a Kahoot to go over some vocabulary you'll need to do this activity. Okay, the likelihood of something happening. Triangle is probability. The diamond is simulation. The circle is empirical probability, or the square is theoretical probability. Okay, you got that right.
Morgan!
Go Morgan.
Oh, yeah.
Jesus.
The trial to predict the probability.
Wait, I'll take our calculator.
Got it right in this six.
Guys, we're gonna do how much can you eat? And so in this, it's cereal boxes. How many of you have ever bought cereal boxes to try to get all the prizes inside of it? Yeah, a lot of us have. So today we're gonna calculate the probability of it happening in this situation. So there are 6 different toys that will be in, or different characters, excuse me, put randomly distributed through all the boxes. And so we're going to calculate, well, first of all, I need y'all to come up with a number that y'all think how many boxes it would take to get at least one of the toys. And just write it on your piece of paper, don't tell anybody, and bring it to me, please. Okay, so for part D, you're going to design and conduct a simulation with your group with at least 15 trials to determine the number of boxes you would expect to have to buy to get to at least one of all 6 characters. So what are some ways we can simulate this? What are some ways?
We could use dice since it has 6 sides.
Yeah, that's a good idea. That's one. Use the dice, and each number represents one of the 6 characters. And you would roll it until you have all 6. Does anybody else have another way?
I guess flipping is one, because there's a probability like of you getting one character and not getting one at all in a box.
Flipping a coin is actually kind of difficult for this problem because there's only 50-50 and we have 6 characters. So do you understand, like, it'd be kind of difficult to flip it for 6?
True, but is there a possibility that you could not get a character at all?
Not when they're equally distributed and randomly distributed throughout all the boxes. Okay, well, we have decks of cards back there, so you could pull out the ace, the 2, the 3, and the 4, and the 5 and 6, and shuffle them each time and pull which card comes out, and that would represent one of your 6 characters, and then you put it back and shuffle them again and pull out another card. And you do that until you got all 6 characters. Or we have little beads, and you can get 6 different colors and put them all in one cup, and you would pull out, and one bead would represent one of the 6 characters. The thing with that is you need to replace each bead after you pull it out each time, because you have an equal number of chances to get each one of the characters. Does that make sense?
And the random number generator?
And we have a random number generator you can use on your calculator. I can come show you how to do that. So work with your groups, and each of you, with your group, you need to decide on a simulation and then conduct 15 trials. So a trial consists of getting all 6 numbers. And you need to count how many times it takes you to get that all 6 numbers. Does that make sense? Okay. Go.
Whatever you want to do.
You only need 1 dot to do this.
You can have 2 trials going on at the same time. No, I don't think it's scary. I like it too.
That's hard.
You want a piece of paper to keep track on your computer, whatever, of how many times you rolled it and how many numbers you got.
Good, different simulations.
You can if you want to, but you don't have to.
We like.
No.
5. What? Wow.
What do we normally get?
So you got 1 through 6? Okay, so you need to count how many times it took you to get that. Okay, that's 1 trial. So you need 15 of us.
Try to get all of them. 1, 3,
That's 1 trial though.
4,
Okay, y'all, we're gonna do 5.
5, 4, 3.
Because we've already done 15 trials.
You're supposed to roll the dice for 1 trial consists of getting all 6 numbers. So you have to roll it until you get all 6 numbers. Once you get all 6 numbers, that's 1 trial. And then you have to yeah, okay. Is y'all gonna get it? Okay, yeah.
I think they're all good.
Okay, so that's your first number. Don't do the empirical yet. Okay.
Most people. Just kind of take this over.
Don't do this careful yet.
Hey, we finished doing our own.
Okay, so bring me your numbers, like how many times, just so you can get.
Just bring it up and stuff.
And then you'll start the class.
I think it's every count. It's 8 times.
Yeah, it's the count, like this one's 21 times, this one's 8. Make sure those are.
Okay.
Oh,
She's like, wait, what kind of dice?